Alright, here's a demonstration of our program to draw Sierpinski triangles and H-trees. Now, if you've seen our presentation, you're aware of what these two shapes are and look like. The main function of interest that does the meat of the work is the GUI. Obviously, there are a lot of different sub-functions to describe the different shapes that the GUI can draw.
Triangle works by drawing a main initial triangle. Past that point, there's a counter that determines how many levels are left to draw. Based on coordinates of the previous larger triangle, the function recurses, drawing a new triangle over the old one based on the old coordinates. This version uses different colors for triangles on the left, on the right, or above, as you can see in the else case of rest recursion 1. This function runs by the sides button.
D-triangle does the same thing, but the colors are organized by level rather than position. It's just two different team members' approaches to coloration. The function runs the by levels button. Here is a box. If you recall the idea of levels from the presentation, to input the desired number of levels, you push the Input button so the new information is taken in. 4 is the default. You can see how the color changes with the number of levels.
Now, you can see an example of by sides, and you can see how color changes based on position. That's all that's meant by the different buttons, then. H-tree works on much the same principle, utilizing the idea of levels and basing coordinates recursively on the previous coordinates.
S-squares does much the same thing, except with square shapes, showing the general applicability of this idea to other interesting fractally shapes.
The function WebColors isn't actually our work. It belongs to James Bennett, but it's what we're using to define colors for the purposes of changing the colors in the GUI.
Blooper just utilizes the same code as Triangle, except with messed up parameters so that it looks like interesting modern art. And it demonstrates how quote-unquote easy ideas like overlaying triangles is actually rather more difficult than it appears.